Hello, this is Module 3, Primitive Data Types in Java. What we're going to learn now is variable declarations and using variables within Java, which is one of the most fundamental things that all programming languages need. First, it's important to note that there are a number of primitive data types that Java does allow for. They are listed here in this chart. You'll see there's a byte data type, which is an 8-bit signed 2's complement integer. A short, which is 16 bits integer. An integer, and the regular standard int, which is a 32-bit signed integer, as well as long, supporting the long integer operations. Float, which is a decimal number using the 32-bit IEEE 754 floating point standard, as well as double, the 64-bit version of that. A Boolean data type, which is a true and false, and this is different than a 0 and 1, and they're not interchangeable. Some programming languages do allow you to use a 0 and non-zero for a false and true. That's not the case in Java. They are not interchangeable. In fact, conditions must be evaluated to a Boolean value, which we'll discuss later on when we do conditions. And finally, we have a char value as well as a primitive data type, where you can actually have a 16-bit Unicode character denoted by a /u as a special character using single quotes, and then a 4-digit hexadecimal number. So when we declare variables, it's actually very simple. Within our code, we need to decide what type we're going to use. And in this case, we have 3 examples. We'll declare the variable type, integer, and then the variable name, a. And the variable names can be pretty much anything, and they are case sensitive. There are some limitations as to what it starts with. It cannot start with a special character or a number. It must start with an alphanumeric. An alpha character. And so what you find is that we can use int a, so that it declares a variable called a of type integer. And so you'll see me refer to it literally as that. When we ask, well, what does this particular line do? It declares a variable called a, which is of type integer. You see that here. And in this case, we have a variable called z, which is of type double. Another variant of this would be a variable called isCorrect. Okay, and you notice the capitalizations, which is of type Boolean. And we would like to normally initialize these things to certain values. There isn't an automatic initialization, so it's important to note that you should initialize variables when you use them, or at least know that they should be initialized at some point. Java will return variable may not have been initialized as an error. So here are some examples of using this as an assignment. Once we have declared it, we can basically use that variable. So here I have a equals 5.6, assign 6 to the variable a. Here we have z equals 5.6, which 5.6 is assigned to the variable z. Now, what's important to note here is that 5.6, when we have a literal like that, that is actually going to be a double. Java will default decimals as a double, and we'll show you later how to actually use floating point and what would be long values as well. So if you want to use the 32-bit version or 5.6 as a float, and later on we'll show that you'll actually just put an F after this word to denote the float. In this case, a 6 is an integer, so this would actually be not a short, not a long, but the regular int 32-bit standard. So what we might do is we could consolidate the assignment in a single statement and the declaration. Int a equals 6, double z equals 5.6, and Boolean is correct equals true. Notice there are no quotes behind this, and this would evaluate as a Boolean value. If we had put quotes in there, it would be a string. So once we declare a variable, we cannot declare it again within the same scope. We'll talk about scope within methods and classes and even within blocks of code. The variable can only be used once within Java, usually within what we call braces. That will define the scope. So as I mentioned before, when we use literals, the actual values such as 6 or 5.6, Java actually has some default types for that. The default type for numbers that have no decimal point is an int, the 32-bit version, and the default type for numbers with a decimal is a double, not a float. It is important to match types. Java will not automatically do what's called casting for you. Java will return an error if the types do not match. So down here we have integer a equals 56,000, and what would be invalid would be byte a equals 56,000. Similarly, double z equals 5.6, float f equals 5.6. Again, the floating point value is, the 5.6 is a double. This double would not fit within a floating point value, so you would have a problem. Boolean b equals true, which is valid. Boolean b equals 0 is invalid because the Boolean value is expecting a true or false. Converting a string to a primitive isn't straightforward because strings are really a composite variable. The way it works is for every primitive we have a class which has functions that handles conversions for you. So what happens is we may have a string that has the numbers 1, 2, 3, 4. And if we want to convert this to, say, an integer, and this happens quite a bit, especially when we're passing parameters. Some of the example programs actually do this where they actually take an argument from the command line, pass it into the function, and it needs to be converted because those arguments are strings. And so what we'll do is we'll take that string A and pass it into this integer.parseInt. Integer is the class, and .parseInt is a method within the class, and we'll talk more about that later. But what this does is this converts the string A into an actual integer number that can be put in I. And you'll see some examples of that code in the sample code that we have online. That kind of concludes the presentation. There's an optional module here that we'll show you, just to show you how the variables are declared within the function.